One type of inequality is linear inequality, which looks similar with a regular equation except the inequality sign. Check how this type of inequality can be solved here in Mathematics of Engineering. Like linear equations, linear inequalities are those with exponents of 1. They are as simple as having only one term with x, to the higher level of having the x variable on both sides of the inequality sign. They can also be grouped in quantities, or they can have fractional coefficients. In this video, we are going to solve linear inequalities from the easy format to the latter challenging ones. The first one is x less 2 is greater than or equal to 5. Take note that transposition in inequalities is risky, as the two sides of the equation are not the same, unlike when we use an equal sign. So instead of moving or transposing terms, it is safer to do operations on both sides. We can start with adding 2 on both sides of the inequality, which will cancel negative 2 and positive 2 on the left side, and leaving x. The right would also be simplified as 7, so the resultant is x is greater than or equal to 7. To show the answer graphically, we use a number line and identify 7. X includes 7, so we use a closed interval. Then x is greater than 7, so the arrow moves to more than 7 directed to positive infinity. This can be denoted as bracket 7 and positive infinity with a parenthesis. How about 3x minus 2 is greater than or equal to 13? We start solving this inequality by adding 2 on both sides, thus we can cancel negative 2 and positive 2 in the left side, leaving 3x. The right side will also have 13 plus 2, which is simplified as 15. Thus, we have 3x is greater than or equal to 15. Then, to isolate x, we divide both sides by 3. So we get x as greater than or equal to 5. Showing it on graph, we place a closed interval on 5, and the arrow goes to positive infinity to show greater than. So the interval notation will be written as a bracket with 5, and then positive infinity closed with a parenthesis. Take the case of 5 less 2x is greater than 13. We place all constants on the other side by subtracting 5 on the left and the right. So we arrive at negative 2x is greater than 8. To isolate x, we divide both sides by negative 2. So x remains on the left, and 8 divided by negative 2 gives us negative 4. Now hold on with the graph. Remember that when we multiply or divide with a negative number, we flip the inequality sign, so what we got is x is less than negative 4. Graphically, we show this as an open interval at negative 4, as the integer is not included in the answer. Take note that x is less than negative 4, but it is not equal to it. The arrow points to the negative infinity. In interval notation, we translate the graph as negative infinity with a parenthesis, coupled with a negative 4 and closed with another parenthesis. The use of brackets and parentheses are discussed in the previous video. Let's continue with the linear inequality with variables on both sides. 5 plus 2x is greater than 10 minus 3x. You can start with any cancellation, but for discussion, we proceed with the constants. Take out 5 from the left, so we subtract 5 on both sides, and we get 2x left, and it is greater than 5 minus 3x. Now let's group all terms with x by adding 3x on both sides, so we get 5x is greater than 5. Lastly, we isolate x by dividing both sides by 5, and we come up with x is greater than 1. The division we made is with a positive number, so there isn't any need to flip the inequality sign. Now graphically, we can show our solutions as an open interval on positive 1, and the arrow points to positive infinity. The interval notation will then be an open parenthesis and positive 1 with positive infinity followed by a closed parenthesis. Another variation of inequality is as shown. Let's solve 5 minus 2x is less than 3x plus 10. Simplifying the constants, we subtract 5 on both sides to have negative 2x is less than 3x plus 5. Now group terms with x to the left, so we deduct 3x on both sides, leaving us with negative 5x is less than 5. To find x, divide negative 5 on the left and right again, so we get x is less than negative 1. And then again, since we divided the inequality with a negative integer, flip the inequality sign, making x greater than negative 1. To show the solution graphically, we have an open interval on negative 1 and an arrow directed to positive infinity. The interval notation will start with a parenthesis and negative 1 together with positive infinity and closed with a parenthesis. The next case is with quantities. The first step is to distribute terms to get rid of the groupings. Then simplify the resulting inequality, so we have negative 2x less 1 is less than 8x minus 1. Now we can group similar terms by starting with the constants. We add 1 to both sides to have negative 2x is less than 8x. Then to collect similar terms, we subtract 8x on both sides again, to arrive at negative 10x is less than 0. Since what we wanted is the range of x, we divide both sides with negative 10, giving us just x on the left and the same 0 on the right, but without changing the inequality sign. Be reminded that a sign flip comes next after multiplying or dividing a negative integer, so we end with x is greater than 0. To show inequality, we use a number line emphasizing 0 with an open interval and an arrow directed to positive infinity. Furthermore, the interval notation shows a pair of parentheses with 0 as the lower limit and positive infinity as the upper limit. The next inequality involves a fraction, but just the same, we simplify this by eliminating coefficients. So we do this by multiplying 2/5 on both sides to cancel 5/2 with x. We get x is greater than or equal to negative 4. Graphically, we show this with a closed interval on negative 4, and the arrow shows more than as it is directed to positive infinity. For the interval notation, a closed interval requires a bracket with negative 4 paired with positive infinity closed by a parenthesis. A longer fractional inequality is showcased in this example of 5/4 x less 2 is greater than or equal to 3/2 x plus 2/3. The first thing in simplification is to take out the denominator, and that is by multiplying everything with the common denominator, which is 12, thus resulting to 15x less 24 is greater than or equal to 18x plus 8. So we further simplify by adding 24 on both sides to collect the constants. This will turn into 15x is greater than or equal to 18x plus 32. Consequently, we take 18x to the other side by subtracting the same on both sides to come up with negative 3x is greater than or equal to 32. And to isolate x, we divide everything by -3, and we get x is greater than or equal to -32/3 or -10 and 2/3. And again, since we divided with a negative integer, we flip the inequality sign, making our result as x is less than or equal to -10 and 2/3. So to show this graphically, a closed interval is placed in -10 and 2/3, followed with an arrow directed to -infinity. In interval notation, we write the range as an open parenthesis with -infinity coupled with 10 and 2/3 with the bracket.